Hi everyone. This is the chi-square example that's in the lecture. Pardon my little video clip up here. I need to kind of keep my eye on it to make sure it continues to record. But here we go. We've got the chi-square example from the lecture, and I just kind of want to walk through it by hand for everybody. So we have this table up here where we have, we're looking at whether negative emotionality is affected by your gender. So to start with, the table that you get is your observed frequencies. So you don't ever have to find FO. It's always given. So this is our observed frequencies. And here's our chi-square formula. So the first thing we need to do in this chi-square formula is find FE. And if you remember, FE is your row marginal times your column marginal divided by n. So this particular FE for this cell would be the row marginal for the cell times the column marginal for the cell divided by 120. So we'd end up here with 45. The expected frequency for this cell is the row marginal for the cell, the column marginal for the cell, divided by n, 120, and we'd end up with 15. Here, it's going to be 60 times 90 divided by 120, or 45. And here, it's going to be 60 times 30 divided by 120, or 15. So, essentially, what we then find is that these guys here are the expected frequencies for our particular chi-square. So, what an expected frequency does is it kind of tells us what the frequencies would be if these two variables were independent, meaning that gender had no effect whatsoever on whether or not somebody had negative emotionality. And you can kind of see this here. It doesn't seem to matter what gender you are. The spread between high and low negative emotionality is pretty much equal across men and women. So, go away. So there's that. So now what we need to do, okay, let me just check on this recording business. It seems to be going. Come back. So now what we need to do is take our observed frequencies here and subtract each of the corresponding expected frequencies. So when I do this, I like to do this in a table form rather than trying to go this one minus this one is equal to something. I'm trying to put it somewhere. So I kind of flip it into a table. So I put all my observed frequencies here. So this is 46 is female and low, 14 is female and high, 44 is male and low, and 16 is male and high. So we just have to pull the right expected frequencies for each of these cells. So 46 is female and low. The expected frequency for female and low is 45. The expected frequency for female and high is 15. Male and low is 45. Male and high is 15. So you can kind of see I just basically matched this one to this one and then put them on the same row. So the next step is to subtract our observed frequency from our expected frequency. So 46 minus 45 is 1. 14 minus 15 is negative 1. 44 minus 45 is negative 1. 16 minus 15 is 1. So here we are. Again, this adds up to 0 like we saw in standard deviation and variance. So now we square these terms. This is really very similar to standard deviation and variance. So 1 squared is 1, negative 1 squared is 1, and we pretty much know the rest of it at this point. So this is where things start to differentiate, and it looks like everything's kind of turning out equally right here, but this is where things kind of change. So to get this particular part of the equation, our observed frequency minus our expected frequency squared, and then divided by the expected frequency, we've done that top half. Now we just need to divide. So we take 1, which is this top half, right? And we divide that by our expected frequency of 45. So let's see, 1 divided by 45 is 0.02. Okay, so now we've got 1 divided by 15 is equal to 1 divided by 15 is equal to 0.07. We pretty much know what the other ones are since everything's kind of the same. You guys see where I'm going with this? Since all the expected frequencies were pretty even. 15, and there we go. So the only thing that we have to do now is we just need to simply add up this particular column. So now that we've done it all for each cell, and that's what this equation says, is start at the first cell and add it all up for all the cells. We just simply add. So then we end up with, yes, we're still going, yay. There we go. Then we end up with 0.02 plus 0.07 plus 0.02 plus 0.07, and we end up with a chi-square of 0.018. And that's it. That's all that there is to a chi-square.